Hi everyone, welcome back to chemistry. In this video, we're going to talk about 9.5 dilution of solutions. So sometimes we have a solution already and we want to dilute it so that it's less concentrated. So how do we actually do that? So first let's talk about what dilution is. So in dilution, we add water and that as we're adding that water, the volume of the solution increases. And as the volume of that solution increases, the concentration decreases. So the mass of the solute in the solution remains the same, but we're just adding more volume. So looking at our molarity equation, if we are increasing the amount of liters of solution we have, if this is going up and up and up, we're not changing the moles of our solute, right? We still have that number of solute in our solution, but our overall concentration is going to be lower, right? All right, so it turns out that the concentrations and volumes of initial and diluted solutions are actually related by this equation here. And I'm actually going to edit this equation and I'm going to say M1V1 equals M2V2. And the reason I'm changing that is because looking at these two equations, what they're relating is your initial concentration and your final concentration, or your diluted concentration, right? And your initial volume versus your final volume or your diluted volume. So what's my initial concentration and volume of my solution before I dilute it? And what's my final volume and concentration of my solution after I dilute it? So your book says C1, C2 instead of M1, M2. And the reason for that is that your book talks about several different ways that you can calculate concentration. Okay, but for our class, we really only are going to focus on molarity, which is a measure of, it's a type of measure of concentration. There are other ways to measure concentration or to express it. But since we work with moles so often, we're really only going over molarity. For our class, I'm going to recommend that you memorize this equation. And actually, I would give this to you on an exam, so you don't have to memorize it, but you do need to know how to use it. But just so you know, that's really what the difference is there. That's why in your book, you'll see C1V1, C2V2, but in our class, you'll probably see M1V1, M2V2. Okay, same equation, just expressing concentration as molarity specifically. Okay, but the main idea is the same. You're taking your initial molarity and volume and diluting it to get a final molarity and volume. Okay, and you can use this equation to solve a number of different problems. All right, so let's go ahead and try that out. So this question is asking, what is the final concentration? What is the final molarity, right? When 0.50 liters of a 6.0 molar HCl solution is diluted to a final volume of 1.0 liters. So let's go ahead and actually break this down a little bit. So I see that my main goal is to find my final concentration. What's another way of representing that in our equation? What variable is that going to be? Yeah, that's going to be M2, my final molarity, my final concentration, my final molarity, M2, okay? And then my 0.50 liters is going to be what? Yeah, that's going to be my initial volume, my V1. That's my initial volume, okay? My 6.0 molar HCl solution is what we're starting with, right? And then we're diluting it. So we're starting with this. So that's going to be my M1. And then my final volume is given to me. That's my V2, Okay, so I have initially a known amount, a known volume of my initial concentration solution, and I have a known final volume of my final concentration, but I want to find my M2. So let's go ahead and plug these in. So we've got our equation here. So we've got M1V1 equals M2V2. We've got 6.0 molar HCl times 0.50 liters equals, we know our V2, but we don't know our M2, so that's what we're solving for. So I'm just going to write M2, and our V2 is 1.0 liters. Okay, so we're solving for that M2, so we want to get that alone. So let's go ahead and divide by 1.0 liters to cancel that out. So we'll cancel that out. And then we're left with M2 alone. I'm just going to move M2 to the left side just because that's kind of the convention. And then let's check out, let's look at these units. So looking at these units, I have liters on the top and liters on the bottom. What happens if I have the same unit on the top and the bottom? Yeah, it cancels out, canceling out those units, right? Yeah, so this is just like our dimensional analysis problems, where if we start with grams and we want to get to moles, we need to divide by grams to cancel those grams out. So we can cancel out those units. And we're left with units of molarity, which is exactly what we want. We want a final molarity. Okay, so perfect. So let's go ahead and do this calculation. So we got 6.0, or just 6, times 0.5 divided by 1, which is just 3. And let's not lose any of our sig figs. So it looks like we have 2 sig figs all across the board. So we'll keep 2 sig figs in our final answer. So we'll say 3.0. And then what are our units? Molarity. And then what is the solution? Did they ever tell us? Yeah, HCl solution. All right, so that's our final answer. So we got our final concentration. So we were given our initial volume, our initial molarity, and our final volume. And we wanted to calculate, using our equation, our dilution equation, the final molarity. Okay, so what is the molarity of a solution prepared by diluting 0.180 liters of 0.600 molar HNO3 nitric acid to 0.540 liters? So half the battle with these types of problems is figuring out what you're given and where you want to get to. What do I have out of my M1V1, M2V2 equation? Okay, and how did I know to use the M1V1 M2V2 equation? Yeah, I'm noting that I'm diluting something. So that's a good hint that you're going to need your M1V1 equals M2V2 equation. All right, so what's the molarity? So we want to know the molarity of a solution that is prepared by diluting that many liters. So this is my initial volume. And then I'm going to dilute it. Okay, so this is my final volume. I'm diluting from that many liters to that many liters. Okay. And then I've got an initial molarity. So that's M1. And I'm solving for M2. Okay, so this is similar to our last equation, or our last problem, just written a little bit differently. So let's go ahead and solve this. So we've got M1V1 equals M2V2. I'm going to go ahead and solve for my unknown before I plug in any of my numbers, just to kind of show you what that looks like. because I think I said I was going to do that earlier, and I actually ended up plugging in the numbers first. So you can do it either way. It's the same thing. It's just a little bit of a different route. So let's do that. So I'm going to divide. These are being multiplied, right? So the opposite of multiplication is division. So I'm going to divide by V2 because I want to get M2 alone. So that cancels those out. Actually, let me do that in a different color. So that cancels out that V2, and then I've got V2 here. All right, I'm going to rewrite my equation just so it's a little easier to see. All right, so now I can solve directly for M2. So M1 I've got, let's go ahead and color code that. I've got that, let's just put it in yellow. So I've got M1 is going to go there. So that's 0.600 molar HNO3. And then I've got, what's my V1? Let's go, V1 will be green. So we'll put V1 there, that's 0.180 liters. Okay, and then, oops, let me make that a little better. And then on the bottom, I've got V2. Let's go blue for that one. And that's 0.540 liters. All right, let's just do a unit check. So, oh, and let me make this blue. There we go. So let's do a quick unit check. So we want to end up with a molarity, our final molarity. So we know we want molarity alone. So we're going to cancel out those liters. We've got them on the top and the bottom. If you had more liters here, what would your units be? Yeah, you would still have liters on the top. You don't want that. So that would be it's kind of a quick check to figure out, okay, did I set this up right? So check your units first. Okay, so my units look good. So I'm going to end up with a molarity, which is exactly what I want. So let's go ahead and do our math here. So we got 0.600 times 0.180 equals 0.108 divided by 0.540, which is 0.2. That's what came out in my calculator. So let me just make sure we have enough sig figs. We don't want to get rid of any sig figs. So it looks like we start with 3 sig figs all around. So let's just add a couple zeros in here. That decimal place makes this 3 sig figs. If there was no decimal place there, we would only have 1. Okay, but since we have a decimal place there, this has 3 sig figs. So molar, and then what do we have? HNO3 solution. All right, so that would be your M2, your final molarity. So you're taking a 6 molar solution and you're making a 0.2 molar solution. Okay, you're diluting it. Pretty cool. All right. They don't have any more examples, but there are some. So in both of these examples, we were solving for M2, but there are other things you'll have to solve for. So anything in this equation is fair game to solve for. They'll always give you, and I will too on exams, will always give you the information that you need. So you'll always just have one variable that you're solving for, but it's your job to figure out which variable that is. Okay, so let me know if you have any questions as always, and I'll see you in the next video.